Assalamualaikum and very good day to all of you my dear students. I am Cikgu Nurzahan binti Syamsuddin. Today we will discuss on projectile motion problem solving. It is a question 16 from section B from G Cakna Kelantan Module Fizik STPM Sem 1 2020 and 2021 session. Okay, so next we will look at the step-by-step guide to solve physics problem. Actually, you can use this step-by-step guide for any kind of physics problems. Okay, we look at the slide. Okay, look at the step 1. It is clarify the key points or the keyword, which means you need to read the problem carefully. Number 2, identify the chapter and subtopic. And the next one, visualize what is occurring and diagram it. And then number 4, identify the unknown value. Okay, the unknown value, it is occurring in the question. What does it want in the question? Whether it wants the angle, whether it wants the distance, or so on. Okay, next we will look at the next step. Okay, so number 5, list down the given quantities with unit and related formula. Okay, there's a lot of physics equation that we know, but then from the equation, from the problems, there's a lot of information given. List down all the quantities given. Okay, and then number 6, manipulate and combine equation to solve for the unknown, which means there might be more than one way of the alternative method to solve the problems. Whether it is one way or another way, it is a lot of alternative method that we can use, which is as long as it is follow the concept. Okay, the last step that for the physics problem guides, perform unit analysis and calculate the value with proper units. Okay, this is very important because some students they do the correct calculating, but with the wrong unit. Okay, before we continue with the question, okay, I would like to discuss some notes from projectile motion. Okay, look at here. When a ball is thrown at an angle to the horizontal, its motion consists of two components. A, vertical component, which is motion under uniform acceleration is negative g. And B, a horizontal component, motion with constant velocity. Okay, so next, this is the vertical motion. Okay, this is the diagram for parabolic motion. Projectile motion. This is the theta, and this is range. Okay, x is the distance from origin point to the any point here. Okay, so this is the u sin theta for initial velocity. A equals to negative g. Okay, look at height, maximum height. Okay, which one is the height? Okay, so this is the height. Okay, height is the maximum level of this projectile motion. What is height? Height equals to u sin theta square over 2g, and time taken t1 equals to u sin theta over g. The instantaneous height y at any given time t, which is y equals to u sin theta t minus half gt square, and time of flight t equals to u sin theta over g equals to 2t1. Okay, the next one for horizontal motion. Okay, horizontal motion, initial velocity equals to u cos theta. Instantaneous horizontal displacement x at any time t, which is x equals to u cos theta t. The range r, okay, the range r here equals to u square sin 2 theta over g, and the maximum range, okay, the maximum range equals to u square per g. It occurs when sin 2 theta equals to 1, theta equals 45 degrees. Okay, so if you want to find out the maximum range, so the best angle is at 45 degrees. Okay, next. Okay, Okay, this is some of the projectile motion tips that we can follow, that we can see from here. Okay. So, first, to calculate the projectile motion at an angle, first resolve the initial velocity into its horizontal and vertical components. The next point, analysis of projectile motion involves dealing with two motion independently. And the third point, vertical components will always have the acceleration of gravity acting on them. And the fourth point, vertical motion is symmetrical, which is the distance and time are the same in the rise as in the fall. And the final velocity will have the same magnitude as the initial velocity, but in opposite direction. Okay, the next one, horizontal components will never be affected by gravity. It is constant velocity motion. Okay, this is the diagram for projectile motion. Okay, if you can see here, okay, this is the V. V is not on the x-axis or y-axis. This is the direction of the V, velocity. This is the initial velocity. Okay, and then this velocity is resolved into two components, Vy and Vx. Okay, so at this we can see here Vx. Okay, Vx equals to constant. Okay, look at this. Okay, Vx always constant. Okay, so when it is constant, we can say that the Ax or the acceleration is equals to 0. And at this, okay, and then for vertical component, okay, constant acceleration. Okay, this is for vertical component. Okay, if you look at here, the value of Vy is equals to the value of initial velocity. Okay, same magnitudes. It has same magnitude but in opposite direction because of what? Of this sign. Okay. Okay, so basically this is the total velocity at a point which has resolved. Okay, this is the diagram here for this one. Okay. Okay, next. Okay, so I have enlarged this image for projectile motion. Okay, so where is the U? This is the initial velocity. So the initial velocity is resolved to two components, Uy and Ux. Okay, how do you know Ux equals to U cos theta? How does you know Uy equals to U sin theta? Okay, let's say we're doing a triangle diagram here. Okay, so so this is U, and then this component we consider it as Ux. This component we consider it as Uy. So this is theta. Okay. So from here, okay, basically, okay, look at cos theta. Okay, cos theta equals to Ux over U. So U cos theta U cos theta equals to Ux. Okay, so it is like that. Okay, the same method we can use to find the Uy. Okay, at this maximum point, if you look at here, maximum point or maximum height Uy equals to 0. Okay, for maximum range, when the displacement is at 0 here. Okay, this is the solving problems involving projectile motion. Okay, we divide it into horizontal motion and vertical motion. Okay, we have discussed before that at horizontal motion, since Vx is constant, so Ax is equals to 0. Okay, look at what is the possible equation for horizontal motion, which is Vx equals to Ux and Sx equals to Ux times delta T. Okay, this one. Okay, look at the vertical motion. Okay, vertical motion. Okay, y, Ay. Okay, at A is the acceleration equals acceleration for component y, and equals to g gravitational acceleration equals to 9.81 meter. Sorry, this one actually ms negative 2. Okay, we doing some correction here. Okay, not ms negative 1 for velocity. For acceleration is ms negative 2. Okay, vertical motion. Okay, at vertical motion. Okay, if you consider here, when I'm talking about vertical motion, okay, look at y. Okay, this is one for vertical motion. Okay, Vy equals to Uy plus G delta T. Delta T here referring to the time taken. So, and then next one, the displacement Sy equals to Uy times delta T plus half G delta T square, and Vy square plus Uy square equals to 2G S. Okay. Okay, so now we look at the G-Chapman equation. Question number 16. Okay, let's read it together. A projectile is fired with a velocity 60 meter per second at an angle theta from a horizontal ground towards the roof. Okay, from a horizontal ground towards the roof of a tunnel of height 5 meter. If the projectile just barely touched the roof and assume that G equals to 9.81 meters ms negative 2, determine the angle of projection. Okay, so what we will do after we read the question, highlight all the information given here. First, velocity 60 meter per second. Next, height 5 meter. And what is the another known value? Okay, G 9.81 ms negative 2. Okay, so we have the known value, 3 known value here. Okay, what is the unknown value? Angle projection. Okay, so we can write, okay, what does it need? Okay, so we just write the symbol, okay, put the question mark. So this is what we want. Okay, there's a lot of equation that possible to use this to solve the problems. Okay, based on the information given, so we can select or choose what is the most related equation for this part. So angle projection, okay, we can use V square equals to Uy square plus 2s. So we are considering for for vertical motion. Okay, this is the diagram. Diagram to help us to solve the problems. So this is the theta. Okay, look at here. This is the V naught. This is V naught sin theta. This is the V cos theta. Okay, somehow it is written. You can write as U. Okay, also you can write as V naught. Okay, V naught and U is initial velocity. Okay, this is the maximum height. This is the range. Okay, so look at the solution for question 16A. Consider the vertical motion. Okay, consider the vertical motion here. Okay, let's say at vertical motion Vy square equals to U square plus 2as. Okay, at vertical motion Vy equals to 0. Okay, since A, okay, look at here. Okay, since A at vertical motion, we are considering on gravitational acceleration, which is equals to negative 981 ms negative 2. So 60 sine theta square. Okay, this is the Uy. Okay, so 60 sine theta square plus 2 times negative 9.815.0, and we rearrange the equation. Sine square theta equals to 9.81 over 60 square. Okay, sine theta 0.1651. Okay, it's not still. Okay, and then from this sine theta, we need to obtain the theta. Okay, the theta or the angle of projection is 9.5 degrees. Okay, so the angle projection is 95 degrees. It's quite low. Okay. Okay, the next one. Question B. Time of flight of the ball from the starting position of his hand to the position horizontally same level to his initial hand. Okay, so what should we do after this? Okay, so look at this part. Okay, so this is Vy. Vy equals to 0 at the maximum height. Okay, this is the time taken that we need to find out. Okay, so if you look at here, what is the possible equation that we may use for this problems? Okay, so first one, we can try this equation. Sy equals to ut plus half at square. Okay, so Sy 0, Uy 60 sine. Okay, 9.5. Okay, how did you know 9.5? Do you still remember the value that we get in question A? So we got it at that theta equals to 9.5 degrees. This is obtained from the calculation that we find from question A. Okay, so substitute theta equals to 9.5 plus half 9.81 t square. Okay, we need to find the t or time taken. Okay, and then so we got t is at 0 or t at 2.02 second. Okay, this is what does it mean? Okay, where does the t at 0? Okay, this is t at 0. Okay, this part t equals to 0 to second. Okay, this is the movement of the projectile motion. Okay, besides you want to use the equation. Okay, we have another alternative method to find the time taken for this part, which is you can use this equation. T equals to 2uy over g, or uy. Okay, uy equals to u sine theta. Uy is the velocity at component y. Okay, y component or y direction. Okay, so 2u sine theta over g. Okay, substitute u is 60, theta 9.5, and g 9.81. Okay, so we got the theta equals to 0.2 second. It's still giving you the same answer. Okay, the next one, question C. Okay, this is the last part of this question. Okay, question C, which is giving you 2 marks here. Okay, so range projectile motion. Okay, which part is projectile motion? Okay, look at this is the range. Okay, from the first point to the final point. From the first point to the final point. Okay, this is the range. Range is the distance. Okay, range is the distance. We need to find the range of this motion. Okay, this is the height. Yeah, height. Okay, so what is the equation for the range? Okay, So we can use Sx. Okay, since it is on the x component or horizontal component, so you may use Sx equals to u. Okay, maybe, okay, this is the basically we have learned before. S equals to ut plus half at square. Okay, for this part, range, since range is for the x component, so Sx equals to uxt plus half at square. Okay, Sx is the equals to the r. Okay, A. Okay, A is referring here, it is the acceleration of x component which is equals to 0. Okay, that's why half at square equals to 0. Okay, so we rearrange the equation. Okay, from Sx equals to r. Okay, r equals to uxt and r equals to 60 cos 9.5 degrees. Okay, times 2.02, and we can obtain that. We can find out that r equals to 120 meter. Okay, so this is the final answer. Okay, so how do you feel? Is it okay? Is it easy? It's easy, right? Okay, so for students out there, so that's all our discussion for today. So hopefully you are enjoy with our discussion. So thanks for watching. Assalamualaikum.